Good afternoon, Pre-AP Physics. We are going to talk about 2.1b, throwing objects up from a height today. So here's our problem. You're standing at the top of a 45-meter tall building. You throw a ball up with an initial velocity of 3.5 meters per second. Then you have several questions to answer. First, let's label the picture from what we know from the problem. If you are standing at the top of a 45-meter tall building and you throw a ball up with an initial velocity of 3.5 meters per second, that means that this height here is 45 meters, not the total height. Okay? It also means that my velocity up from here is 3.5 meters per second. Now, one thing that is standard in all vertical problems is that acceleration is a negative 9.8 meters per second. And that is true for every problem that we do. So now let's get started. We're going to copy this piece of information so that we can transfer it to all the other slides and label as we find things. Oops, there we go. All right, so now copying that over, let's go answer that first question. What is the velocity at the highest point? All right, velocity at the highest point. What is the equation I need to find velocity at the highest point? That would be v is equal to v naught plus at. V is my velocity up here, and that's always going to equal 0. That's that momentary pause. 0 is equal to 3.5, that's the initial velocity I threw it up at. Remember that up is positive and down is negative, minus 9.8 t. Grab a calculator, solve that equation, and you get 0.36 seconds. 0.36 seconds. So the time up is 0.36 seconds. So now I'm going to make a copy of the new grouping and transfer that to the next page. So now I have a velocity, initial velocity, a time up, and an initial height. So how much time will it take to get to the highest point? Oh, silly me, I answered that question too. I answered that on the first slide, didn't I? The velocity at the top was 0 meters per second. We'll just add that back in here. Velocity at the top is 0 meters per second, which answered the previous question. And now we've answered it again. So let's move on. How high is the highest point? So essentially, I want to know where this point is. Well, our equation for height is y is equal to y naught plus v naught t plus 1/2 at squared. And plugging in what we don't know y. That's what we're trying to find. Right there, I want to know y. Y is equal to, y naught is actually 45. That's the height from over here. Plus V naught, that's what I threw it at, 3.5, times that amount of time of 0.36 seconds plus 0.5 times a negative 9.8, remember that acceleration always goes down, times 0.36 squared. Again, grabbing a calculator. 45 plus 3.5 times 0.36 plus 0.5 times a negative 9.8 times 0.36 squared should give us a maximum height of 45.62 meters. Y should equal 45.62 meters. Notice if you didn't toss it very hard, it didn't go very much higher than where it started. So we're going to add this piece of information over here. Y, the maximum height, is 45.62 meters. Hopefully getting all of this to join as a group. And going to the next page. The next page is, what is the velocity now? What is the velocity of the ball when it hits the ground? So I want to know the velocity down here. In order to find velocity, I'm going to use kinematic equation 3. V squared is equal to V naught squared plus 2A delta Y. Remembering that delta Y is the entire height. So our initial velocity, and this is a little confusing, our initial velocity is actually the velocity at the top because we want to find this velocity at the ground. So we turn the tables, and this initial velocity at the top is 0 plus 2 times. Acceleration is a negative 9.8, but remember your rules of exponents, that when you have something squared, the thing can be squared and it can be negative, but you can't take the square root of a negative thing. So we just take the negative off of the 9.8 and we're going to put it back on after the problem. So our height is 45.62 meters. Grabbing a calculator and solving for V, I need the square root of 2 times 9.8 times 45.62. And I get a velocity at the bottom of negative 29.9 meters per second. So this velocity down here at the ground is a negative 29.9 meters per second. Again, we're going to grab all of this information, group it together, and copy it so that we can take it to the next slide. The final question is, how long did it take to get there? Well, we have our time up. Now we need to find our time down. Time down should be a rewrite of y is equal to y naught plus v naught t plus 1/2 at squared. Because we're looking at it from the falling object aspect. We want to find the time down. So this should be the square root of 2y divided by a. And again, when you're looking at this, remember a cannot be negative because we can't take the square root. Time is also never negative. So this is the square root of 2 times that maximum height of 45.62 divided by 9.8. Again, grab a calculator, take the square root of 2 times 45.62 dividing by 9.8. and you get a time down of 3.05 seconds. So what is the total hang time? The total time should equal the time up plus the time down. Remember from over here, the time up was 0.36 seconds. The time down is 3.05 to make the total time up 3.41 seconds. Total time of 3.41 seconds. So that was your last sample problem for 2.1b. Now what I want you to do is get your reading assignment out. You had a Unit 2 reading assignment number 2. And on the back, that should be blank, answer these two questions. Compare and contrast throwing objects up from ground level and throwing objects up from a height. And number 2, what piece or pieces of information are or is necessary to solve vertical motion problems? Bring this back to class with you next time. Thanks for watching.